Do you like videos on the internet? Do you like video analysis? Do you like physics? Well, here we are. A video. Let me play this. I've already got it loaded in tracker video, and so it's not perfect, but this is a video. DK Metcalf catching a football. 2 versions. Play. I put them side by side. Which one's real and which one's fake? Or are they both fake, or are they both real? They can't both be real because they're different things, right? So on the video on the left, he obviously goes a lot higher. I started off with a video on the left. I did an analysis, a video analysis, and I found that the acceleration, the vertical acceleration was very close to, close enough to 9.8 meters per second squared that it seemed legitimate, at least plausibly legitimate. Someone posted the second video and said, "Oh, here's the real version. It's unedited." And I'm not really sure what to do, so let's just do a video analysis. I put these two things together in Keynote because that's what I like to use, and you can do that. You could do it in Final Cut Pro too, but you use the tools that work for you. Tracker Video Analysis is a free program. Let's just start this thing up. I want to start with the jump, let's say. And I try to get these synced, these two videos synced, and they don't look exactly synced. But see, because right there, they don't look synced. I'm looking at the arms. And they may be different frame rates or something. But see, these look... that's pretty close right there. Don't you think? That's weird. Okay. And I don't want to fix the video. We can figure that out all later. Now, let's go ahead and start working on this. I'm going to put a coordinate axis right down here. In my previous video, I did move the origin a little bit. The camera moves a little bit, but not a ton. And since I have the same two videos, the camera's going to move in the same way. So I'm just not going to worry about that. I do need to scale the video. So let's, I looked up that DK Metcalf has a height of 1.93 meters. So let's just do that. I'm going to go up here to, and I apologize if everything's too small. Move that down a little bit. So I'm going to go to new calibration stick. It puts this little stick right here. I'm going to put it at the top. Let's make this bigger because I just can't see. Okay. There we can see. I need to put this at the top and the bottom. So I'm going to kind of approximate. There's his heel to his head right there. Let's say that's 1.93 meters. So I'm just going to type in here 1.93. Okay, total approximation anyway, it doesn't really matter. Next, I need to mark the location of his center mass in each video. And if he stayed in a standard standing up position, the center mass be right around his belly button. I'm pointing to my belly button and I'm touching it, and you can't even see that. And I'm still doing it. I'm still touching it. So I'm just going to have to kind of approximate it. But what I definitely want to do is do the same thing for both videos. So I'm just going to approximate it on this left video, and then when I go to the right video, I'm just going to try to do the same thing. So I'm going to go up here and say new point mass, and this is the one that jumps higher. So I'm going to rename this name DK Super because he jumps higher. And now I'm just going to approximate, and I'm a little. I wouldn't normally do this video this early because he's not really jumping yet. But so here's his belly button. He's in standard position. He's moving down a little bit. I'm going to try to. And as he moves down, though, you'll notice that his legs are coming up. So he's in a squat position. So his center mass is not at his belly button right there. It's a little bit higher. So I'm going to just kind of move that a little bit higher. I'm just going to be fair. I'm going to try to be fair. So now his arms are swinging up. So that's going to move his center mass up a little bit. It doesn't have to be perfect. Now his arms are moving up. I'm looking at that line on his shirt. Arms are moving up. I'm going to be at the line now. Let's scroll this up. So let's say right there, at the line, at the line, at the line, at the line. Now his legs are going to start coming up. Well, not yet. I'm still at the line, at the line, at the line, So, and pulling your legs up is a way to keep your center of mass moving up, even though you do not. So I'm going to be, that line actually moved up, so, because his shirt pulled up. See, it's not, that center mass can't be that high. I'm just kind of estimating here. See, it's still above his belly button. I'm at his chest level now, because that leg's up, and that leg has mass. And I'm just approximating. As long as I do the same for both of them, it'll be fine. And I'm not going to do the same. I'm going to try to do the same. Okay, so he contacted the ground. Let's do one more. Just so we can... A couple more. Okay. Now let's go over to the other one. And I'm going to say new point mass. And I'm going to call this one name DK norm. So let's scroll over to this guy. Let's see. This one. I'm going to go back to the beginning. Back to the beginning. Okay. And I'm going to try to do the same thing. So here I'm just going to say I was marking about right here. Oh, what the heck happened? Come on, man. Let's just play it, see what happens. Oh, I was like zoomed into 2000 to fit. Okay, let's see. That's weird. Why does it go black? Okay, there we go. Let's go to 200%. Okay, I think we're back on. In jump phase. And I'm going for that line again. Remember, I was aiming for that line. And whether it's a center mass or not, as long as I'm the same, it doesn't really matter. I just got to be fair, equal. Fair video analysis. Okay, now it's in his chest right now, which is probably not the best, but that's what I did before, I think. And then I remember going on his leg like this. Okay. Let's do some analysis now. So this is X position I don't care about. This is normal. Let's analyze his Y position. So I'm going to analyze, and I'm going to curve fit. So if he is a projectile, then I should fit a parabola to this, and the term in front of the t squared should be 1/2 acceleration. So we can get the acceleration. So I'm going to go to analyze, curve fit, parabola. And you'll see it doesn't fit perfectly. It doesn't match very well up there, but again, that's a center mass issue. But down here, I get an A term of 3.5, negative 3.5. So if I multiply that by 2, I get 7. So that's, I mean, we're looking for 9.8. We're looking for 9.8. Okay, let's do the same thing for the other DK super and analyze that. Here we go, do the same thing. Analyze, curve fit, parabola. And this one has 5.44, so that's going to give me an acceleration of 10.88, which seems closer. And the shape looks better, right? This is my original analysis. I did this one. I was like, well, it kind of looks legitimate. It looks like a parabola, even though I'm guessing at the center mass. And so I said, hey, it could be real. So why are they different? And that's the thing that's really bothering me, is that they both take about the same amount of time. So let's do a comparison. We can do this. I can go compare with, and this is super. I want to compare with normal I'm going to say okay. Now let's analyze this. So you'll see that I think what happened is one of these, this could be real, right? It could be real that it's not parabolic at the top because he's changed his center mass, but this part and that part should be. And so this one, maybe they just, I don't know, they just stretched it up. It's really weird that they take the same amount of time. That could be it. It could be a frame rate difference. Let's go back over here, click this. This has a frame rate of 30 frames per second. So it's possible they just changed the frame rate on one of the videos. If I go back over here, analyze. Let's try this. Let's compare the Y velocity, Vy. Now, this is the rising part. Let's analyze that. And I don't know that I can easily, let me turn off these Y's. I don't want the Y. I don't want the Y. So now I just have velocity. So let's just fit a linear function to that part of the data right there. Analyze, curve fit, line. Oh, that's the jump. That's why that has to be why he's jumping. If his velocity is increasing, oh. But this, let's see, so that's a time of, that must be during the jump. It has to be, right? Let's see, what time is this? At a time of 1 second. So if I go back to the video, I don't know what this is not behaving right now. Okay. If I go back to the video, drag that over. It's not dragging over. That's fine. So if I go back to the video right here, and let's just go back. Okay, jumping. Okay, that is jumping. Okay, that's right. So then this is the part where he's accelerating. So analyze. So this is the part. So if I fit a line to there, that has an acceleration of, that's, it looked like, well, I did this before, and that is the same acceleration I got before. This one has a slightly lower acceleration. I can't fit that one. So let's go to norm. Let's go over here, DK norm, and fit the velocity. Analyze. Turn off the Y. I don't know why that, I really don't want to see that Y. And I'm going to fit right here. Oh, not all that, just this part. Analyze, curve fit, line. And you'll see that I have a slope of negative 6.6. Again, that's not right. The acceleration is too low. Okay, well, inconclusive, right? I'm going to say inconclusive. If I had to pick, the one that has the better physics is the one where he goes higher. I mean, that is a 1 second hang time. It's not impossible. But when you look at them, I think the one that's lower seems a little bit better. But that's what makes this stuff so much fun, is that no one really knows. Okay, that's it. I'm done. I did this video before. The audio is messed up, so I'm doing it again. And I still am finding the same thing. So I guess I got to go travel out there and just go see DK Metcalf and make my own video. That's what I need to do. I should do that.